Assalamu alaikum. Let's start with our lecture today, and we are going to start with the new topic, and the topic is soil classification system. So in this topic, we are going to cover two types of classification system. One is called Unified Soil Classification System, and this is sometimes also called ASTM classification system. So this is one that we are going to study, and number two, we are going to study H2O classification system. So far we have studied uh, how to calculate the percentage of gravel, sand, silt, clay. So whenever we do the sieve analysis, we get this S-shaped curve, which is called the gradation curve. From this gradation curve, and remember, on this gradation curve, horizontal axis is the particle size or the grain size. Mostly it is in millimeters, and this vertical axis is the percent passing from those sieves, percent passing. Sometimes we also call it percent final. So from here we get is the percentage of gravel. What is the percentage of gravel in this soil, the percentage of sand, and the percentage of fines. How much is the fine in this soil? And if there's a requirement, we are going to calculate Cu and Cc, coefficient of uniformity, coefficient of curvature. So there are some situations when we do not calculate Cu and Cc, and we are going to see that. Then in some situations we might have to calculate the Atterberg limits. Remember the Atterberg limits. If you recall the previous topic, the previous lecture, it was on Atterberg limits, and in Atterberg limits we do liquid limit test and we do plastic limit test, and from liquid limit, plastic limit, we calculate plasticity index, which is liquid limit minus plastic limit. So in order to classify the soil, we need following information. We need the percentage of gravels, percentage of sand, percentage of fines, coefficient of uniformity, coefficient of curvature, liquid limit, and plastic limit. If we have all these informations, then we are ready to classify this soil. Now let's start with the unified classification system. This unified classification system is based on ASTM D2487. This is the standard that is followed. Okay, and remember, American ASTM stands for American Society for Testing and Materials. So this is ASTM stands for American Society for Testing and Materials. American Society for Testing and Materials. So ASTM, so ASTM D2487 is used for this, and remember, this D series is for soils and rocks. Okay, and this test was developed by Casagrande in 1946. So this unified soil classification system is based on Casagrande. Now in this system, the most important thing is the percentage passing from sieve number 200. So let me write here. Okay, so if you remember, in sieves, when we are going to distinguish between gravels, sand, and fines, for gravels, the upper sieve is 3-inch sieve, the lower sieve is number 4, and for sands, for differentiating sands and fines, it is number 200 sieve. And remember, the size is 75 millimeter, and this is 4.75 millimeter, and this one is 0.075 millimeter, or sometimes we can write 75 micrometer. Okay, so anything which is going to pass through this number 200 sieve is called fines. Okay, so fines, these are passing from number 200 sieve. Everything that is going to pass through number 200 sieve means the materials whose size is smaller than this sieve is going to pass. So this is sometimes also called E200. E200 is passing from number 200 sieve. There is another way of writing retained on 200 sieve, R200. It means the material that cannot pass from 200 sieve, the material that is going to retain on number 200 sieve. So R200 is retained on number 200 sieve. Okay, suppose here is my sieve. This is number 200, and we pass some material through this sieve. So some of the material is not going to pass through this sieve because the particles are bigger, so they are going to stay, and some material is going to pass through because the particle size is smaller, so it can pass through the opening. So we have to look at what is the percentage. Suppose if passing through this sieve, suppose if you calculate the percentage, you know how to calculate. If you calculate the percentage, if passing is 80%, means 80% of the material is smaller than this sieve opening, then the material that is going to retain on it is going to be 20%, because the total has to be 100%. So remember, passing 200 plus retained 200 is always equal to 100%. Okay, similarly I can also write, let's say, P40. Now what is P40? P40 means passing, percent passing, actually it is passing from number 40 sieve. So for this classification system, P200 is very important. So why it is very important? Because we are going to look at what percentage of P200 is for any soil. Okay, so if P200 passing from 200 sieve is less than 50%, okay, then we call that the soil is coarse grained. Coarse grained. So whenever I say coarse grained, means it will contain the first letter is going to be gravel, G, and sand, either gravel or sand. And if passing from 200 sieve is more than or equal to 50%, then it will be called as fine grained. So when it is fine grained soil, it means it is silt and clay. So whenever I say sand and gravel, so it means it will involves the letters. For gravel we have G, and for sand we have for gravel we have G, and for sand we have S. Okay, so we are going to see these two starting letters, and in case of fine grained soil, it will be either silt or clay. So the first letters are going to be M or C. So just remember, the first important point is we have to look at if P200 is less than 50 or more than 50. Or sometimes you can also write it like this: fines are less than 50, or fines are more than 50. So remember, fines is actually passing number 200C. This is the same thing. Okay, so the first important point is we have to look at what is P200. If P200 is less than 50, it will be called as coarse grained soil, and if P200 is more than 50, it will be called as fine grained soil. Now, the typical classification convention is shown on this slide. So here is one example of classification. This is the one example. So this one is the group symbol SM. It means it's a sand, but it contains silt. Sand with silt, or I can say silty sand. But if you want to see the description, this is complete description. It says silty sand with gravel. So here from this symbol I can read it has silt and sand, so I can say silty sand. But what about gravels? That information is not here. For that you have to go through the table, and then the complete information will be silty sand with gravel. Maybe there is another soil SM, and the detail is going to be only, let's suppose, silty sand. It is also possible. Okay, so for fine grained soils where passing 200 is more than when passing 200 is more than 50%, in that case, as I told you, the first letter is going to be M for silt, and C for clay, and O for organic. Organic soil means the soil that contains organic material. So if there is no organic material, we are not going to use. So mostly we don't encounter organic material. Maybe there might be some situations, there might be some sites where we are going to encounter the organic material. Mostly it is going to be inorganic soil. All the soils are inorganic soil. It doesn't contain any living organism. It doesn't contain any remains of the plants and trees and roots, all that stuff. So the first letter is silt and clay, and the second letter is low. L for low plasticity, H for high plasticity. If you remember that chapter of soil plasticity, we talked about this diagram that is called the plasticity chart. And on that plasticity chart there is an A line, and above A line is the soil that is going to fall is called clay, and below A line is called silt. And if the liquid limit is more than 50, then the second letter is H, and if the liquid limit is less than 50, the second letter is L. Horizontal axis is liquid limit, vertical axis is plasticity index, and in this shaded area we have CLML. This is 4 and 7. So if you remember, we studied in detail this P chart. Okay, so in case of coarse grained soils, granular soils, the first letter is going to be sand or gravel. Okay, and the second letter is going to be either poorly graded, well graded, or it might have some significant amount of fines. So second letter is going to be M or C. So these are some of the examples. So if you look at, there are 4 plus 4, 8 basic symbols, 8 symbols for coarse grained soils. And if I'm not going to consider the organic soil, so there are 4 symbols for fine grained soil. So it means 8 plus 4, there are 12 symbols for classifying the soil. There are 12 distinct symbols. There are some situations when these symbols are going to be grouped. There are some borderline cases where they are going to be grouped. Now the first thing that we have to look at is the particle size, and I have been talking about this in my previous lectures from the beginning. What is the criteria for sand, gravel, silt, clay? So for gravel, it has to pass from 3-inch sieve, but it has to retain on number 4 sieve. So that thing will be called as gravel, and the short symbol for this is G. and anything that is going to pass number 4 sieve and it is going to retain on number 200 sieve, that is called sand. And anything that passes through this number 200 sieve is called either silt or clay. Now silt and clay combined is called fines. So that actually silt and clay, general word is fines. Now how we are going to distinguish between clay and silt? For that we have to look at this P chart as I talked earlier. So if you are above this A line, it is going to be clay. If you are below this A line, it is going to be silt, either L or CH, and this is ML or MH depending on what is the liquid limit. So remember, for the definition for the clay is it's the material that passes from number 200 sieve and it is going to plot on or above A line on the plasticity chart. For case of silt, it is the same, passing from number 200, but it is going to plot below A line on plasticity chart. And for sand, these are the pieces of rocks that are going to be between number 4 sieve and number 200 sieve. They are going to pass from number 4 sieve, but they are going to retain on number 200 sieve. And for gravels, these are the pieces of rock that are going to pass from 3-inch sieve and they are going to retain on number 4 sieve. So all these terminologies, nothing is new. We have discussed it already. Okay. There is another kind of soil which is called organic soil. You might not encounter at most of situations. So it's a soil that has sufficient organic content in it. So how we are going to determine if a soil is organic or not? So if it is an organic soil, it will have a certain smell in it, and there is going to be certain color. So from the color and smell, you will come to know that it has got some inorganic organic material in it. So what we do is we take 2 soil samples, sample 1 from the same soil, and then we take sample 2. Let's say we have sample 1 and we have sample 2. Now the sample 2 we are going to do is oven dry. Okay, we are going to put this sample in an oven. The temperature is kept more than 100 degrees, maybe 110 to 120. So after 24 hours minimum, we are going to carry out on this oven dry sample the liquid limit test, and we will find what is the liquid limit value. Suppose the liquid limit value comes as, let's say, 35. I'm just assuming, giving you an idea. And the first sample we did not put in an oven. We directly do the liquid limit test, and the liquid limit value suppose comes as okay, let me say 52. So for sample 1, liquid limit is 52. For sample 2, which is oven dried, it is the same soil, but it is put in oven before doing the test, and liquid limit value is 35. Now we have to look at how much liquid limit has dropped. So that drop in the liquid limit is going to be, so we have to look at if its liquid limit value after oven drying is less than 75% of the liquid limit before oven drying. So this is our base value. So it is going to be 52 minus 35 over 52 times 100. So let's look at, if I do this calculation, 52 minus 35 is 17 over 52, and we get percentage. So this percentage is going to be 32.69. So the drop is 32.69. So you have to look at what is the actual value. So the actual value is 35 over 52 times 100. So drop is 32.69. If you subtract it from 100, so that is 67. Actually, the oven dry liquid limit is 67% of the normal sample. So this value is now less than 75. So if it is less than 75, that soil will be treated as organic soil. So this example that I just wrote here, it is an organic soil because the liquid limit is going to drop too much. It is dropping more than 25%, right? It is 32%. It is more than 25. So this soil is organic soil. Same case is the for the silt, and peat, it is a very a special kind of soil, or it's a clay. It's actually that contains a lot of moisture in it. It contains vegetable tissues in it, and they are in the different stages of decomposition, and it will have very strong smell, and we cannot build any structure on this soil because that soil is going to be too compressible. That is called peat, and we always are going to reject this soil. So if there is some peat at any location, we have to remove that soil and we have to replace it with another kind of soil. So this was the terminology about the particle size. Next is well graded, poorly graded. So this word well graded, poorly graded is used for granular soils, and you have studied this in the chapter of mechanical analysis. If you remember, we calculated two coefficients: coefficient of uniformity, coefficient of curvature, and these coefficients tell us if the soil is well graded or poorly graded. Remember, well graded soils have a big S shape or when we make the gradation, and the poorly graded soils, they have very narrow this gradation curve. So that is well graded W, and this is poorly graded. Poorly graded is also called uniformly graded, and those things, they come from this these two values: coefficient of curvature and coefficient of uniformity. If Cu is high, then chances are that the soil is going to be well graded. Okay, now we have seen some of the terminologies. We have already talked about this is how you calculate Cu and Cc. For Cu and Cc, we calculate D10, D30, D60. You know how it is calculated. D10 is the diameter of 10% passing, dia of 10% passing, and similarly dia of 30%, dia of 60% passing, and from there you calculate the coefficient of uniformity and coefficient of curvature. And these coefficient of uniformity and curvature will help us in deciding if the soil is poorly graded or if the soil is well graded. So remember, the higher value of Cu will give us well graded soil. If Cu is equal to 1, it means there's just one particle size. There's just one particle size. This is hypothetically, but maybe we are not going to look at, we are not going to exactly find the value of Cu exactly 1. It might be close to 1, 1.2, 1.3, 1.5. One particle size only, if it is 1. So the minimum value of Cu is going to be 1, and what is the maximum? There is no upper limit. As this number is going to increase, the soil is going to get well graded, and higher the number, better is the soil. And the second is coefficient of curvature. This is always between 1 and 3. If C is from 1 to 3, we say that the soil is well graded. If the value of Cc is less than 1, or if the value of Cc is more than 3, in that case it will be called as poorly graded. Poorly graded is also called uniform graded, means one particle size or less particle sizes. So well graded curve has always very big, a long stretched S-shaped curve. Okay, one more thing here is important, is that if the percentage of fines, if passing number 200 sieve is less than 5%, then it is called clean sand and gravel. It is called clean sand and gravel. And when passing number 200 is less than 5%, we don't need liquid limit and plastic limit. We cannot perform liquid limit, plastic limit test. So please remember, you should always keep in mind that when passing number 200 is more than or equal to 5%, in that case liquid limit test and plastic limit test is needed. We need these values, otherwise we cannot do the classification. Okay. So second kind of gradation is called poorly graded. So poorly graded means they have mostly same size particles, one size particles, and whenever the curve is vertical, mean these particle sizes are missing. So if you look here, it's a gap graded. There are certain particle sizes which are missing. So this, with what I'm shading this with yellow highlighter, they are missing particle sizes. So I can say that these particle sizes. Okay, no, there's a mistake here. Uh, this horizontal component is actually missing, this one. So this particle size from here to here, so this is missing particle sizes. And those who are vertical, these are actually the sizes which are available in this soil, and this is also missing, and this is also missing. They are not present in this soil. Okay. Okay, so in this classification, unified soil classification, if in case of sand, if Cu is more than 6, then we say that it is well graded soil. If it is less than 6, it will be called as poorly graded. For gravels, this threshold is number 4. If Cu is greater than 4, it will be called as well graded, and if Cu is less than 4, it will be called as poorly graded. So you don't have to memorize these two values. Just remember Cu is greater than 6, and in this case Cu is less than 6. Here Cu is greater than 4, and here Cu is less than 4. Okay, now I'm going to now summarize here first for the coarse grained soils, those groups, and then for fine grained soils, and then we are going to look at the table. Okay, let me insert here a slide. So let's first talk about the coarse grained soil. Remember, for coarse grained soil, passing from 200 sieve is always less than 50%. Or fines are less than 50%. Okay. Now, fines are going to be less than 50%, so it means there are 3 possibilities. Number 1, okay, let me draw here 3 scenarios. Number 1, this fines, let me call it fines, or you can call it P200 or fines. So P200 or fines are less than 5%. One possibility, they are less than 5%. Second case is when it is from 5 to 12%. And the third case is it is from it is greater than 12%, but it is less than 50%. So I am going to just write greater than 12%. But they will be up to 49 point something, when up to 49, because when it is 50, it goes into another category. Now there are further 2 divisions, and that division is for sand and gravel. So we are going to use this word gravel when the percentage of gravel is more than that of sand. For example, if I say that the gravels are 30% in any soil, sand is let's say 25%, and the fines, okay, what is 30 plus 25 is 55, so this is going to be 45. Okay, 30 plus 25 plus 45, it is 100. Okay, so the summation is 100. If I take this soil, so I see that the gravels are 30% and sand is 25%, and fines are 45%, and because this fine is less than 50, it is a coarse grained soil, but it is going to be called as gravel because gravels are more than sand. So when gravel is more than sand, and passing number 200C where fines are less than 5%. So there are going to be two groups here only. Either it will be well graded gravel, or it is going to be poorly graded gravel. So there are two possibilities. Now when it is more than 12%, then we are going to break it into four categories. It is going to be either the gravel with clays and gravel with silt. Okay. Or there is another possibility, and that is the dual GC-GN. Yes, this is also possible. So there are three groups when fines are more than 12%. What about between 5 and 12? So here, when it is 5 and 12, there is a dual gradation. It is going to be either well graded gravel with some clay, GWGC, or I can write GMGC. Okay. There is another possibility, GWGP, means it has a large percentage of silt, or it is going to be GMGP. Actually, the first means this is well graded gravel with some clay. This is okay. The second letter I did a mistake here. The second letter is poorly graded. So here I messed up. GWGC, or it is going to be GPGC, and here is GWGM, or it is GP and GM. Okay, so these are well graded gravels or poorly graded gravels with some amount of silt and clay. Okay, same way, if the gravels are more than sand, then the first letter is going to be, if sand is more than gravel, it is the same way, but the letter now is going to be S. It is either SW or SP. Well graded sand, poorly graded sand. Okay, and here it is going to be called as SC. It's a silty clay sands with some clay, or it is going to be SM, sands with silt. It is also called silty sand. Or if we combine them, it is going to be SC-SM. It means this sand contains both silt and clay, and when we are going to mix them together, this is a borderline case, so it is going to be SWSC, or it is going to be SPSC, or it is going to be SWSM or SPSM. So if you look at total are going to be, in case of gravels, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are total 9 groups. And in case of sand also there are 9 groups. And I'm considering those borderline cases as well. So there are 18 groups in case of coarse grained soils. The next one is the fine grained soils. So fine grained soil is easier than this coarse grained case. Okay, so in fine grained, the passing number 200 is less than 50%. Okay, now in case of fine grained soil, we have to look at the liquid limit, because the dividing is the liquid limit. Remember, whenever it's a fine grained soil, you will directly go to P chart, and from that P chart you will come to know what kind of soil it is. And even if you don't want to draw the P chart, then this is how we are going to divide. Liquid limit is less than 50, and the second case is liquid limit is more than or equal to 50. When liquid limit is less than 50, there are there are two scenarios. It is going to plot above a line. So whenever I say a line, we are talking about P chart. So if it is above a line, or it is going to be below a line. Or there is third category, third case, it is in the shaded area. Remember, there is a shaded area in the P chart. So if you look at, so this is that shaded area, and this is that A line. Above is CL or CH, and below is ML, MH, and this shaded area is CL dash ML. This is a dual gradation here. So if it is above a line and the liquid limit is less than 50, it will be called as CL. If it is below a line and liquid limit is less than 50, it will be called as ML. And when it is in shaded area, it's a dual classification, CL-ML. You saw in previous case there are so many dual cases, but in case of fine grained, it's only one dual case. Now when liquid limit is more than 50, the same way, if it is above a line, this will be called as CH, and when it is below a line, it will be called as MH. So there is no shaded area, because after 50, when the liquid limit is 50 or more, there is no shaded area. Okay, so there are 1, 2, 3, 4, 5. There are 5 categories for fine grained soil. So remember, for coarse grained, there are 18 groups, and for fine grained there are 5 groups. So if we add them together, so in unified soil classification system, total there are 23 groups of soils. We can divide the soil into these 23 groups. So whenever we are going to take any soil into the lab for testing, it will be among these 23 groups. Okay, so let me show you those charts now. There are some flow charts. I'm not going to talk about. You can see it is in your notes. You can go through the same way I explained on those slides. It is all shown on the flow chart. So I'm just going to skip these. You can see it yourself. The same information. Okay, this is the same information, and that is also the same information. You go through this through this flow chart, and you are going to find one of those 23 categories. Now, what is the procedure? The procedure is, we are going to take the soil, and it should be, if there are some lumps, it has to be broken, and then we are going to carry out the sieve analysis. After doing the sieve analysis, we will see what is passing number 200. So if passing number 200 is less than 5%, no need for liquid limit and plastic limit test. Okay, but if this value is 5 or more, then we have to carry out liquid limit and plastic limit test. And after collecting all the information about, okay, let me summarize here. What is the information that we need? The percentage of gravels, percentage of sand, percentage of fines, maybe a CU, CC, and liquid limit, plastic limit. There are some cases when we are going to skip. When we have all these 5-6 informations, then we are ready to classify a soil. So this is a flow chart. This is a chart for classifying those soils. So if you look at this fine grained soil, we have 1, 2, 3, 4, and 5 groups. I'm not considering these organic soils, right? So there are 5 groups for this fine grained soils. So we are going to go through, and then we are going to end up in one of the categories. Here on this chart, something important is written. Here is written 30% plus number 200C. So what does it mean, plus number 200? Plus number 200 means it is retained 200C. Okay, it's not passing. Whenever there is a plus word, it means retained on that C. But if you look at the the coarse grained soils, this is the chart for coarse grained soils. So for coarse grained soils, as I told you, we have 9 categories for gravel. 1, 2, 3, 4, 5, 6, 7, 8, 9, and there are 9 categories for sands. 1, 2, 3, 4, 5, 6, 7, 8, 9, and they depend on number one. First dividing line is if the fines are less than 5%, between 5 and 12, and more than 12. So when it is between 5 and 12, we have this dual classification. When it is between 5 and 12, this is the dual symbols. These are dual classification, dual symbols. So these are two charts, very important for doing the classification. And we also need this P chart. You know what is this P chart? We have discussed in much detail in previous chapter. So that is the A line, and for that A line we will be using this equation. Plasticity index of A line is equal to 0.73 liquid limit minus 20. So this is the value of plasticity index on A line, but remember this equation is only valid when the liquid limit is greater than or equal to 25.5. If the liquid limit is less than 25.5, then we are not going to use this equation. When the liquid limit is less than 25.5, in that case plasticity index of A line is going to be equal to 4. So there are actually two equations. When liquid limit is less than 25.5, Pi value will be 4. When it is more than 25, then it is going to be a straight line equation. So that is actually 25.5. This value here is 25.5. Okay. So we covered the basic idea about unified classification system. There are two groups, and then how we group them into those 23 subgroups. In the next lecture, I'm going to do some examples on unified classification system. So please, when you watch this lecture, please do make your lecture notes. Write down important information on your notebooks. Thank you so much, and have a great day.